Let's handle this infinity minus infinity case. Here's another indeterminate form. So we got our infinity over our infinity. We got our 0 over our 0. Now what about infinity minus infinity? Now you've seen it, and I claim it's not going to equal 0 every time. Sometimes it will. Sometimes it absolutely will. Sometimes it'll equal 7. Sometimes it'll equal negative 1/2. Sometimes. So let's get into some of these problems. Now we've already defined what L'Hopital's rule is. There's a bunch more words, but here it is. The indeterminate differences. We get an indeterminate of the form infinity minus infinity. This is not necessarily 0. I keep repeating this thing because it's not. Usually it is best to find a common factor, or I don't know, I just find a common denominator and just make it into an infinity over infinity or 0 over 0 case, just by using it with algebra first. Then you use your L'Hopital's. I write cat minus dog equals apple because infinity isn't a number. It's just some weird ass concept. And we're saying infinity minus infinity. You know there's different sizes of infinity? This shit's so weird. It's basically like trying to say cat minus dog and trying to claim it equals something. You're like, sure, let's call it an apple. Let's call it a box. It doesn't mean shit. It means do more work. All right, infinity minus infinity means do more work. Let's go. So there's the problem that we left off on. Now, if you're to go and plug this thing in, we're taking our limit as x tends towards pi over 2 from the left-hand side of tangent of x minus secant of x. I'm going to tell you the tangent of x is undefined at all odd multiples of pi over 2. So is secant, because they both have a cosine in their denominator, and cosine of pi over 2 is equal to 0. That means that they have themselves a, they got a problem in their denominator. So tangent of x, just a quick little sketch for you. Right, it repeats over and over and over and over and over and over. You know what I mean? But they're all at these multiples of pi over 2. All right. We have these issues, but we can see the tangent's taken off to positive infinity. So we go over here and we're like, well, the tangent's positive infinity. Minus, now what's going on with secant? Now secant looks more like this. Right here, 1. Since it has the same domain issues, right, the odd multiples of pi over 2, it's also blown up into infinity. We'd have to know which side this thing's going to, but it really doesn't make much difference. I mean, if this was a infinity minus a negative infinity, infinity plus an infinity, well, shit, that's infinity, right? That's infinity. It's already infinity, then you're adding more shit to infinity. Oof. All right, so just had to confirm. There it was. There it was. We got it. Cool. So let's go through and let's do this problem. And the game is, they have the same denominator. If you've ever taken a class with me, you know. Shit, I can't. Wow, that was weird. You know that I preach the same thing when it comes to trigonometry. You all spend so much time trying to memorize everything and like catch every damn. Dude, there's only sine and cosine. Now do a little bit of freaking algebra. Y'all know this shit. Now put that stuff together. Now put this together and see if we can't come up with the L'Hopital's. What's that? Sine of x minus 1 over cosine of x. Now let's go. You plug that thing in. Sine of pi over 2 equals 1. So if you look off to the side, this is 1 minus 1 over cosine of pi over 2 is equal to 0. So you got that 0 over 0 case. Okay? 0 over 0 means now we can do some L'Hopital's rule. The only real difference that we have here with the problem is we just had to do a step of algebra first. And that's actually the hard parts to these problems. It's the algebra first. It's not the freaking calculus. Calculus is freaking basic. It's all the shit that comes with it. So the derivative of sine is equal to cosine. The derivative of 1 is equal to nothing, so we'll leave that shit alone. Derivative of cosine is equal to negative sine. And there we have it. The limit is x tends towards pi over 2 from the left-hand side of, and maybe many of y'all are going, negative cotangent. Sure, you can call it cotangent. You got cotangent memorized? I don't. I'm the freaking teacher. Let's plug that shit in. We get cosine of, and we just plug in our a, which is pi over 2, over negative sine of pi over 2. See, I know those values. I know this shit was going to work. I knew we could plug this thing in because I know cosine and sine, just cosine and sine. Cosine of all odd multiples of pi over 2 is equal to 0. Sine of all odd multiples of pi over 2 does not equal 0. Sine of positive pi over 2 equals 1. So we get negative 1 down below. Doesn't really matter. Our answer is 0. Oh shit, didn't I say that it doesn't always equal 0, but it keeps seeming to equal 0? It's like your teacher doesn't know what he's talking about or something. Oh well. Well, let's just try one more problem. Let's do one more and we'll be done with this. We'll have one more video afterwards, and we'll wrap up our L'Hopital's. Now this one is the limit as x, and I think this one might be in your textbook. It could be. I'm not certain. But I think this is a classic. I've seen this one a few times. I just found this one in textbooks I like using quite a lot. And let's go get this thing and let's look at it. So first, I just kind of want to graph up 1 over x minus 1. So that means we just have a shift over. And a shift over. Oh, sorry, there's a parenthesis around that. All right, cool. So it's going to 1 from the positive side, we're going up to infinity. So you got like an infinity case there. Minus, and then 1 over, negative 1 over ln of x. What's ln of 1 again? 0? Let's look at this thing. So what happens is this 1 is going towards this, as we're getting closer and closer to 1 from the positive side. Because here's 1. We're getting closer and closer. We're going this way. The height goes to 0, right? But it's going to 0 from the positive values. So it's saying the denominator is going towards 0. So what happens is the denominator gets really, really small. Guess what? It blows up to infinity. That's some of the weird shit you got to start understanding. Huh? That's not simple. Dude, that's not simple. You'd have to know that since the denominator was going towards 0 through the positives, that since it was a 1 over that quote-unquote 0, we must be blowing up to infinity. We got to start getting those concepts down, and especially, you want to be ready for Calc 2? You don't understand that? You won't even understand how to start the damn problem. That's a lot of the concepts we use, is what's growing quicker, what's going on in the denominator. So get your practice with it. Let's make sure that we're ready to go, and that we're going to be the students that walk into our next class ready to ready to kick some butt, right? I'm not redoing the whole thing because of that. All right, let's go. Let's create a common denominator. So what would we need to do up here? Let's look up our problem. So this would need what, an ln of x up top, and then an ln of x match, and then this would need an x minus 1, and then this would need an x minus 1. Okay, cool. So we put it together. So we got ln of x times x minus 1. And what was our first one right here? That was ln of x. Minus, and we have 1 times, just x minus 1. Let's make sure to use that parenthesis. We're going to get the wrong answer. All right, cool. Let's just clean it up just a tad. I don't know. It doesn't really need to be cleaned up at the moment, but I just want to make sure that we don't commit sign error. I have a habit of doing these videos and committing sign error. Like at the very freaking end, I'm going to redo the stupid things because I'm too stupid to figure out how to edit these. All right, so we're continuing on. Now let's go plug this 1 in and see what we get. And I'm going to let you know, ln of 1 is 0. Right? And then you got minus 1 plus 1, so you got 0 up top. And then you go to plug that thing in, you get ln of 1 right here. That's 0 already. And then 1 minus 1, that's really 0. So you actually had 0 times 0 down the denominator. Really want it to be that. Oh, and let me make sure to put a big old dot in between these two things, showing you that this is a multiplication of two things. Ln of x times x minus 1. That x minus 1 is not the argument of the natural log. All right. So now we got the 0 over 0. Let's do some L'Hopital's. Let's jump into it. So let's state it. Let's let them know. So let's take a derivative of the top first. Derivative of ln of x is 1 over x. The derivative of negative x is negative 1. Now down below, shoot, we got a product going on down there. This thing's a heck of a thing, but no worries, we know how to handle business. So we're going to take a derivative on L, and we'll leave ln of x alone. And then let's take a derivative on x minus 1. What's the derivative of x minus 1? Isn't that 1? Cool. Plus, now let's leave that x minus 1 alone, and let's multiply by the derivative of ln of x. What's the derivative of ln of x? It's 1 over x. So we're going to multiply by 1 over x. Neat. Well, I'm looking at this. Let's go through, and see, there's a host of different ways we can go from here. I'm just getting rid of these 1s, so we got ln of x plus, and let's write this 1 over x in the front, x minus 1. You know what I don't like? I don't like that 1 over x. It's looking at me funny. I don't want to have to plug all that shit in. I don't know about you, but I don't want to deal with those complex fractions. So let's do just a tad bit of algebra on Let's multiply top and bottom by x. So that's going to go to here and to here. So what do we get? We're going to end up with the limit as x tends towards 1 from the positive side. So x times 1 over x is 1. Negative 1 times x is equal to negative x. We bring this in, we get x ln of x. Oh shoot. We bring that in and that just goes away. Plus x minus 1. Alright, well let's see what we got. Do we have any, seems pretty clean. We can go and plug it in and we get a, shit, we got a 0 up top. We plug it down below. Gosh dang it, it's a 0 over 0 case again. We got to keep going. We got to keep rolling. Alright, diligent. We'll get it. Let's do L'Hopital's one more time. So now we got the limit as x goes to 1 from the positive. And you know what? We're guaranteed to be done at this point. Did you see that numerator? 1 minus x? Look what's going to happen. What's the derivative of 1 minus x? Negative 1. It's done. No matter what happens here. No more freaking L'Hopital's. Now we take a derivative of the bottom. Oh shoot, we got to figure out what the derivative of x times ln of x is. That's right up top. We've already found what that derivative is. Oh shit, we haven't. We found it was something else. Oh no. So let me just write down what it is just for the sake of time, and that's going to be ln of x plus 1. That's what it is. I'll let you check. That's just the, that's just the derivative of x times ln of x converts into ln of x plus 1. We'll let you figure out as to why. And then the derivative of x is equal to, well, we plug this thing in and let's see what we end up with. I think we end up with a negative 1 over what's ln of 1 is 0 plus 1 plus 1. This is equal to negative 1 over 2. And holy shit, we just found one that wasn't equal to an infinity minus an infinity case that started off. And we found out an answer to be negative 1/2. So there are our solutions for our 2 fun-filled problems. I will see you for 2 more fun-filled problems. Probably the more tricky, the last thing we do will be the most important one that you'll need to take on to Calc 2. But knowing your algebra to be able to solve these problems, very good. Get your practice in.